not quite equal to. Inequalities are the less than, greater than, less than or equal to, greater than or equal to, not quite equal to, in other words. Yeah.
I didn't get yesterday.
It's just supposed to be what? EQ. Oh yeah, U. EQU. Thank you. NEQU. Yeah. QUALITIE. Yeah. Inequalities. Yeah. All right. Okay. So you hopefully did this in algebra 1, right?
Yes.
Okay. Good. So what are you gonna do first?
Solve for x.
Great. So minus 7, which should give me negative 16 over here, and then
Yeah, if you're divided by negative.
so we're going to divide by negative 2 and divide by negative 2. And what do you have to remember? Flip the inequality symbol. Anytime you multiply or divide by a negative number, you flip the inequality. So we get x is less than positive 8. Okay, this is the solution, bless you, using inequality notation. And I asked you to graph it on a number line, which for me means you graph the important number you need there. And do you remember how to graph?
Yes, it's a circle.
It's a circle, an open,
Not an open.
an open or closed circle.
It does not include 8.
Good. That means it's not included. You're exactly right. We don't want to include 8 as our solution. And then we need to do what? Shade to the left. Okay. Okay, this phrase is squiggly. All right, shade to the left. Okay, so is the reason we shade to the left because the arrow is pointing to the left?
No.
No, thank you for saying that. Because there, the arrow is pointing to the right, so should I shade to the right? No, don't do that. You have to read the inequality. Now, whatever way the inequality is written, the rule is you always, always, always read the inequality from the variable. Starting at the variable. So I would say I want numbers littler than 8. Where are the numbers littler than 8? To the left. Okay. All right, and same thing here. I want numbers littler than 8. So we want numbers littler than 8, okay? You do not shade because of the direction of the Pac-Man god. All right, AJ.
So we're going to do the thing where if it's greater than or less than or equal to, then you shade in or opposite. Yeah. Oh, wait, no, you shade in for, yeah.
Okay. All right. That was the refresher. Solve each inequality, graph, and express the solution set using interval notation. Oh, you don't know what interval notation is? No. I'm going to show you what interval notation is based on your prior knowledge. So I will teach that in just a second. Okay. So solve each inequality and graph it just like you already know how to do. And then I'll show you what interval notation is. So we have 4 times the quantity 3x plus 2 is less than 9x plus 5. What do you want to do first? Distribute. You're still all madly writing. Are you there or are you writing directions still? You're on directions? Feel free to, solve it on your own while I wait. Always encouraged to be ahead of the teacher.
Is it?
Oh, yeah.
I always got yelled at for that.
Oh, no, because you're using your brain if you're ahead of me.
Yes, that's the thought.
That's the important thing. Okay, here we go. So
Distribute.
Distribute. Thank you. When I distribute, what do you get? 12x plus 8 is less than 9x plus 5. Okay, then what do you want to do?
Subtract the 8, subtract the 9.
All right, so subtract the 9x, and I also heard subtract the 8, Good. So 12x minus 9x is 3x is less than
3.
negative 3.
Whoa.
Divide by 3. Do I have to flip the inequality?
Yes.
No.
She said it was division. Oh,
What's the problem when you go ahead of the teacher? Now, yeah, if you moved your variable to the other side, you would have slightly different steps than yours. Yeah, okay. So here is the inequality notation. If you were going to graph it, Jack, then you would be plotting -1, and you'd use an open or closed circle.
Open.
Open circle, and we would shade to the left because we want numbers littler than -1. So we're going to shade to the left. Okay, that's a great solution, but this is Algebra 1. This is the solution for Algebra 1. So now that you guys are in college algebra,
Are we?
yeah.
We're in college already?
Keep it or not. No, you don't get college for this. You do get admitted to college for this, though. All right. So interval notation. If you have a graph like this, interval notation is very cool. We want to know the interval of solutions. How many solutions are in this shaded area? An infinite number of solutions, okay? And so we want to express those using interval. All right, interval notation. How far to the left does this arrow go?
To infinity. Negative.
Oh, okay. So over here, all the way to the left, it goes to negative infinity. And yes, that's negative infinity. That's how I write it. Okay.
It's glasses.
It looks like a pair of glasses. I know. All right. So negative infinity, it maybe if you wanted me to write it, okay, that's what it should look like. But that just takes too long. Okay.
Speedy fish.
All right. So negative infinity, and then over here, we get really, really close to -1. When we get really, really close to something, we use parentheses. Parentheses mean close to, but not including. Just like our less than symbol means you get super duper close to, but do not include -1. Okay.
So negative infinity, comma, -1.
Negative infinity, comma, -1 inside of parentheses.
Is it parentheses or brackets?
Parentheses.
Oh,
Yes.
Oh, you like them square, don't you, Adrian?
Okay.
well, no, brackets is like.
All right. We'll talk about brackets in just a second. All right. So over here we have -7. This is the interval notation for this. So I like having the graph because then going to the interval is actually really, really easy. Okay. All right. -7x plus 4 over 3 is greater than or equal to 6. What do you want to do to
Multiply
solve?
both sides by 3.
Okay, I love that. Multiply by 3. Okay. So I'm -7x plus 4 is greater than or equal to 18. Subtract 4. So -7x is greater than or equal to 14. Divide by -7 and flip the inequality. So we would say x is less than or equal to -2. So here is our inequality solution. I'm going to graph that on a number line. So -2, open or close circle?
Close.
Closed circle because it's equal to, so we are allowed to equal it. And we use solid dots and solid lines when we're allowed to equal something. And then we want numbers God bless you, less than -2. So we're going to shade less than -2. Okay, so there's our graph on a number line. So again, I want interval notation. How far to the left does this go?
Negative infinity.
Can I ever equal -infinity? No, I cannot. I can never equal it, and that is why we use a parenthesis. We get infinitely close to it, but we never actually touch it, okay? So because we can never equal infinity, it's always a parenthesis. Over here, it's a bracket. Yes, it is. This is where brackets come in.
So it's like
A bracket we use when we're allowed to equal something. All right? Wait, I'd have to look at these.
I don't know.
so like that.
All right. You'll notice I like to point this out. On the bracket, do you see the equal sign?
Yeah.
Oh, look at that.
That's a thing. Oh my god.
Okay. So from -infinity to -2, we get to include the -2, but not include the infinity because we're never going to get there anyway. Okay. So included. -2 is an answer. Yeah.
So you're saying you never go to infinity and beyond?
Yeah. Darn it. Buzz Lightyear, man. Okay.
My childhood is over.
Just, yeah. I'd be pretty impressed if you ever got to infinity. All right. Example 2. Solve each conjunction. That was a new word for me. Conjunction. What do you think a conjunction is? Combination, yeah. That was a term I hadn't ever read before in any of my math books, so I'd always heard it as compound, meaning more than one. So these are examples of conjunctions. Yeah, I was just thinking that. We will be graphing this. Okay. All right. So what this is we have an inequality here on the left that we can solve. And we have one on the right that we could solve as well. We could solve them separately, but it's much easier to solve them in tandem, so to speak. Okay? Yeah, together. Okay. All right. Graph and express the solution sets in interval notation. So here we go. We're going to solve these in tandem. Our goal is to get x in the middle. All right, so when we have a conjunction, we want x all by itself in the middle, between our two symbols here, okay? So what do you want to do first?
Multiply by 5.
Sure, times by 5 everywhere, on the left, on the right, go crazy. So -30 is less than 9x minus 3 is less than 15. So we're multiplying by 5 everywhere, not just... All right, and then we need to add 3, and so we're going to add 3 not only in the middle but everywhere on the left and the right. Again, there's really 2 equations going on. We're just solving them simultaneously. Okay.
Because we're just that awesome.
All right. -30 plus 3 is -27, and 15 plus 3 is 18. Okay, and then we need to
Divide by 9.
divide by 9. Do I need to flip my inequalities? No. Okay. So I get x all alone in the middle, and -3 and 2. Okay. So this is our inequality that our compound conjunction or compound inequality. I'm going to graph this on the number line. And what we have are two interesting values here. I have a -3 and a 2. And whoops, I'm going to use two different colors so that you can see X. All right, so here on the left, I have one inequality that says I want numbers greater than -3. Where are the numbers greater than -3? To the right. They go to the right. They actually go to the right forever. Okay, they go to the right forever. But I'm not going to draw them forever on purpose. We'll talk about that in a second. And then over here, I have another inequality that says I want numbers less than 2. So that's open circle at 2, and that would be shading to the left. And it technically goes on forever. But when we have a conjunction, that X has to work for both. So it's in between. Yes. So we only show in between. So for instance, if I were to test a value like 4 and say, hey, is 4 less than 2 and greater than -3? On this side, is 4 greater than -3? Yes, that's true. But on this side, is 4 less than 2? That's false. Okay? And so that is not a solution. We want numbers that work for both of these inequalities, and that's the stuff in between. Okay, the overlapping region. Okay? Now, an interval notation.
Is it braces?
Is it parentheses or a bracket? Parentheses at -3 and a parenthesis at 2. So the interval notation is from -3 to 2. Why is it parentheses?
Not sure.
Not included. Not included. As in batteries not included.
Oh my god.
Do you know what all of my kids' first sentence was? It's out of batteries. It's out of batteries. Everybody's first sentence. All right. All right. This might tell you a little too much about my parenting. I love iParent.
You talking about an iPad?
Yeah.
iPad. She's making a joke about how she didn't parent her with an iPad.
Oh yeah, they've had them since birth. All right. Letter B here, ladies and gentlemen. What do you want to do first?
Add 2.
Add 2 on the left and the right and the middle. And so we get -15 is less than or equal to 3x is less than 12. And then
Divide by 3.
divide by 3 everywhere. So we get x in the middle is less than 4 is greater than or equal to -5. So that was easy. And again, shading here, I have a -5 and a +4 at this left-hand side inequality. I want numbers greater than or equal to -5. Should I use an open or a closed circle? Closed circle included -5 through the closed circle. And which direction should I shade? To the right a little bit. All right. And then over here on the left, open or closed circle at 4?
It's a open.
Open circle. And we want numbers littler than 4. So we're going to shade in between the overlapping region. So what's the interval? -5 to 4. Bracket. Parenthesis on the middle. That was awesome. Okay. All right. Do you have any questions for me?